welcome Dr. Erika Pärn to deliver the guest speech today about digital twin system in the built environment. Welcome.
So thanks, everyone. Thank you for the warm welcome. So today I will talk about our recent book, which we published together with my co-authors, called Twin Systems. And I don't know how many of you are currently working on your PhD or your thesis. If you thought a PhD or a thesis was difficult, well, try writing a book with 4 professors. That's a challenge. So anyway, I took on that challenge, and it was about a year's long debates, I would say, where each and every one of these professors and myself, we brought our own different perspectives of what is a digital twin for the built environment. One of the reasons why we wanted to write this book was something similar to the BIM handbook. We wanted to try and, demystify what would it mean to have a digital twin for a building, for our infrastructure, and how do we transition from BIM to digital twins? Because there's so many different interpretations and definitions at the moment, and very little guidance for industry trying to come to grips with what a digital twin actually means for our built environment. So that's what we tried to do. And one of the reasons why we think that this book does matter is that we're trying to explain the ways in which we're moving away from a static design package to a more dynamic interaction with our digital twins. It's much more than just trying to optimize the way that we maintain our assets. There's so many other things and ways in which we can start thinking about digital twins for our built environment. And I'm really pleased that, Dr. Michael Greaves was able to provide the foreword for our book. And I've worked with Dr. Michael Greaves, who is often cited as the pioneer of this term, digital twins. But it was actually Dr. Michael Greaves, together with John Vickers from NASA, who first presented that, used that term, digital twins. But even before John Vickers and Michael Greaves, there was a book published by Michael Geltner back in the 90s, which was titled Mirrored Worlds. And that was more like a sci-fi book, which was trying to project what would the built environment, what would society look like if we had a digital mirror of everything that encompasses our built environment. And one of the reasons we use the term twin systems is because inherent, and one thing we all agreed on within, the co-authors of the books, is that the built environment is a system of systems. If you think about this building, hospitals, schools, universities, they interface with our social systems, so those that occupy the spaces, the general public, and also the natural systems, the natural world. And the built environment isn't an entity of its own. It really is a complex system. And so therefore, if we're going to try and digitally twin them, we should also think about how we can do that with a systems perspective. So some of the things that I'll cover today is, first and foremost, discussing what do we mean by twin systems? How do we define twin systems in our book? What is a twin system life cycle? So we all know about the life cycle of a building, how we start from, concept design into the handover and the operations of a building. But what about a digital twin, and what of its life cycle? Then I'll cover a little bit about connectivity and how we think that the digital twin is not a revolution. It's actually just an evolution of technologies that have come today, and the role of AI and automation, and some of the challenges that we will face as we progress with digitally twinning our built environment. So what are twin systems, and why did we go down this road of describing them as systems? One of the first ways that we like to explain this is to use the brain-body analogy. So if you think about the human brain and you think about its relationship with our physical body, much of what we do happens automatically, almost as an instinctive reflex. But this has been learned behavior over time. And so the digital twin is very similar to the brain and its relationship with the body. with the physical asset. So the way in which we describe the digital twin is it's kind of like the asset brain. And we want to eventually get to a stage where that asset brain is able to dictate and act upon within the physical spaces. So just like if I were to put my hand over a flame, I already know instinctively to move my physical body away from that flame. If you take that analogy to our built environment, by having a digital twin, which is connected to the physical asset, you can actually enact changes within the physical spaces that are dictated by the digital twin. So let's dig deeper into that concept of how we use that analogy. One of the benefits of having a digital twin, or if we think about it as an asset brain, is that ability to both look into the past and look into the future. So one area is by acquisition of continuous data, we have the ability to do forensics, understand what were the decisions that were taken, and why did we let those bad options die in a simulated world, and then move forward with the changes in the real world. The other ability that's critical is the ability to do forecasting and simulation. And we do daily simulations in our head as well, right? We have gathered enough insight and information and learned behavior to then know how to behave in the real world. And this is very critical to the digital twin concept. But the relationship between the digital and the physical is very critical to also have the capability to monitor what is happening. And that monitoring functionality, that can come from so many different sources. Most of it today happens through people. We do have, of course, IoT devices. We have sensors embedded in our buildings. We have building management systems that are collecting data. But a lot of that information is also monitored by those that occupy our buildings, those that manage our assets. So there's still a lot of humans in the loop that are doing that monitoring for us. And then the critical part, which is where we get to the digital twin, is when we can act upon those decisions in the real physical realm, whether that happens autonomously or with a human in the loop. Today, on a construction site, it's very much dependent on a human in the loop. In a manufactured setting, if we're talking about offsite construction, some of this may be autonomous through machinery, but the action part is critical to understanding the transition from a static BIM package towards a digital twin, where we're actually able to enact some of those changes with the physical asset. And eventually what we're trying to achieve are, optimum results and potentially gaining increased knowledge in the asset as it matures over time. This bit of status and intent models thinking, this is coming from Professor Rafal Sachs. So when we started, discussing, okay, so what does a digital twin system actually encompass? Let's break it down into how we would structure that information. So one of the things that he talks about and he brings to this book is the constant comparison between the intent model and the status model. And this is the way in which we describe it in the book. So if you take our intent model, the intent model simply refers to what we intend to build or design or construct. Today, this could be a BIM, so this could be 3D model drawings, PDFs, Excel spreadsheets. Think of all that information that we have, which represents our intention of what we're going to construct, design, build, or operate. In the past, we used to do this with scale models as well as drafting. Scale models are not so common anymore, and we prefer to do this in a digital method. So then eventually this leads us to either constructing or building that building or road or bridge or asset in the physical world. But then the next critical step is really to have the capability of monitoring what's happening. And by having that monitoring capability, we create a status model. And by comparing the status model with our design intent model, this is really what we describe as a twin system. So we don't really confine the definition to only just having a digital replica of that asset, but it's the constant comparison between what was the design intent of those that were originally either responsible for that asset. And this could be happening in various different life cycle stages. We could be talking about the design intent. We could be talking about the construction sequence intent, and then what's happening on the construction side. And we could be talking about the maintenance intent, and then what is actually happening when that asset is being maintained. And so all of that encompassed together is really what we use to describe the twin system. So again, it's very similar to what I just described to you. All of the different stakeholders, whether you're an architect, a structural engineer, or a planner, you have your own conception or understanding what that built asset is. And we often even use different classes to describe those assets, different frameworks to describe that information. When we refer to a physical twin, we're talking about scale models. And if you think about the history of how we got to digital twins, everything we used to do in the past was using scale models. Before you manufactured a car, you used to build scale models of those vehicles with wood. Before we planned an invasion during war, you would create a mock-up, a sandbox, a scale model of that scenario. That's a physical twin. The difference now today is that we've moved onwards from a physical twin to having a digital twin where we can create those scenarios in a digital environment and test out whether or not our hypotheses work. So that's what we mean by a physical twin. But for us, when we talk about a twin system, we're really talking about all of this encompassing together, the constant comparison between the design intent, the status model, giving us the twin system. So what about the relationship between the physical asset and its digital twin counterpart? So one thing I want to highlight here is that when we have our physical asset and the digital twin, it really requires this continuous monitoring and iteration of information that's acquired. Because just like the brain, as you mature and you get older, hopefully you also increase and mature in your wisdom. And the same concept applies with a digital twin. As you collect enough information over time, what you're trying to do is increase your knowledge or wisdom about that asset, whether how it's operating, what works, what doesn't work. So it's not only just about using twins to enhance the decision-making, it's really to also possibly then use that digital twin beyond the lifespan of the asset that it represents. Another thing to think about, particularly when we're talking about the type of information and breaking down the information within our digital twins, is to take note that you really are going to be twinning two types of layers of information or data, one pertaining to the product and one related to the process. So what do I mean by this? So if we take the physical asset and we take the physical world, even just taking this lecture hall as an example, when we say physical product, we're referring to the floors, maybe the ceiling tiles, the lighting fixtures. Those are the physical products. But the counterpart to that will be a process, whether it's how much electricity is consumed, who initially installed those panels. So there's always a process associated with that product. And so when you're building a digital twin, you inevitably have to think about those two relationships as a system and what it is that you are twinning, whether it's a digital twin product information or a digital twin process information that you're trying to twin, or the combination of both of them in many cases. So that's an important breakdown of how we look at both the physical and the digital counterparts. And then one of the things that we discuss as well is connectivity and the relationship between different digital twins. So when I talk to other industries, and before I joined the civil engineering department, I worked with the Institute of Manufacturing. And most of my research was looking at how other industries like automotive, like aerospace and defense, how do they monetize digital twins? And one thing I learned that was critical was that a digital twin is not always one centralized digital twin. oftentimes what you're dealing with is multiple different digital twins exchanging information with one another. So one of maybe the misconceptions and maybe one of the pitfalls of our industry is to continuously assume that everything is going to exist in one centralized digital twin. But the reality is that the built environment is a complex system with lots of different suppliers, each competing with one another. So if you think about the real world, you could imagine that the lighting provider will have a digital twin of the lights in your building. And eventually what they're trying to do is potentially use that digital twin to optimize a service to the building owner or user. So you inevitably will have different digital twins exchanging information with one another. And those relationships will also vary. And one of the things we talk about is that it's something akin to a diagram or almost like a spider web diagram, a network of digital twins exchanging information with one another. So you're not necessarily always going to have that single source of truth. What you'll probably end up with is either a digital twin where you have one-to-one relationship with two twins, you might have a one-to-many relationship or a many-to-many relationship with digital twins. Ultimately, this is mostly going to be dictated either by the private company or a government body that then requires the use of that digital twin. Or if it's not a private company, it's a service provider that's trying to sell you, the building or the asset owner, a service. And the way they deliver that is by having a digital twin of what is happening to your building or what's happening on your construction site. And then let's move on to the life cycle of a digital twin. So many of us in the built environment, we already know about the life cycle of our buildings. We might start with the client brief. This then moves on to the concept design. Then we go further, we create a more detailed technical design, then starts construction, and then hopefully the project comes to a nice end and we hand it over to the end user. But what about the life cycle of a digital twin? So what would a digital twin's life cycle look like? And so that's something that we discuss as well. We like to use the analogy similar to the human life. So if you think about it, as we progress over time, we start with the planning. On the top side of the graph is the digital information or the digital twin as it grows and develops. And on the bottom is the physical asset as it begins to emerge. Moving from the design phase to the construction phase. And then as we progress towards the operation stage, you can imagine this is akin to you maturing, becoming the early adult, right? So your adult life is the operation stage. By now, you will have acquired design phase product information, design phase process information, construction, process and product information, and also operations, process and product information. Of course, not all of this may be necessarily useful or used during the operation stages, but one would think that at least in the lifespan of that digital twin, essentially what you're doing is acquiring more knowledge and wisdom and data. But the difference here with the lifespan of our physical asset, and again, the difference here between the human body and the brain is that when we die, our brain also dies with us, unfortunately. But with a digital twin, when we demolish that building, the digital twin can potentially still continue to provide value to the next generation of buildings, to the next generation of road networks or bridges. And so, you could think about the digital twin as being almost like immortal. Okay, maybe in a few years' time, we can actually twin our brain and maybe we can immortalize our thoughts and ideas. That's very possible. But for now, I'm using this analogy. So again, one of the things we started to think about was how can we ensure that our construction managers, our city planners, our architects start thinking about this question? What is the life cycle of a digital twin? And if we choose to go down the route of actually implementing a digital twin, then is our client willing to also maintain that digital twin? because the digital twins lifespan, again, can really surpass the lifespan of our physical asset, and it will require its own levels of investment to maintain that data, to continuously monitor that data, to extract value from it. And then if we think about, again, what I mentioned earlier, which is that a digital twin is not a revolution for our industry, it's just an evolution. We're just, again, progressing with the natural course of how these technologies are evolving over time. Many of you will be aware of where it all started. So starting from drafting, moving forward to AutoCAD, and then fast forward to closer to today where we're using BIM. So it's really three core technologies that are evolving over time: modeling, simulation, and monitoring capabilities. And over time, as those three areas of technologies have evolved and improved in their usability, it's really when they converge that we get the ability to create digital twins. Today we're using LiDAR, we're using photogrammetry, we're using image processing to quickly monitor what's happening on site. Tomorrow, those scanning technologies will evolve. For example, one of the projects that I've just started, we're looking at new methods of scanning called muon tomography, and using those scan methods to actually assess what's happening to reinforced concrete to our buildings. So if we take the analogy of these three core areas evolving over time, where does AI fit? Well, AI is kind of like the water that is necessary to grow that tree. AI is really what has increased and significantly developed all of these three areas, both modeling, simulation, and monitoring. And if we take, the overall evolution of where we are today, I would say that we're not yet, fully matured up to the treetop. We're sort of in between. There's so many things that we could be, growing to do with digital twins. We could be using digital twins for verified disposal of materials, for performance prognostics, improved maintenance and repair of our assets, energy optimization, rapid prototyping, health and safety compliance. But the reality is that we're still, as an industry, as a whole, we have a long way to go before we can actually generate some of the valuable use cases that we've seen in the manufacturing industry so far. So that's really how we envisage the evolution of twin systems. And what about the challenges then? So one of the bigger challenges that I looked into this a long time ago, I would say about 7 or 8 years ago, we talked about cybersecurity with BIM and digital technologies. But the reality is that anything with an IP address today becomes vulnerable. And so for industry, cybersecurity is one of those areas that becomes a risk, and something that, companies don't really willingly want to take that risk. So cyber physical hacking is definitely one area that we should be conscious of as engineers, as the builders of our national infrastructure. Anything that we then twin with an IoT network, with monitoring capabilities, and also with the capability to actually autonomously action in our physical world, we run the risk of actually disrupting our physical operations. I don't know if you guys have been following the news, but I've been told that Heathrow Airport is shut down today because there was a fire at a substation. Now, this is speculation, but many substations, many oil and gas refineries, many chemical processing plants have a lot of restrictions when it comes to digitizing them because they're constantly at the risk of cyber physical hacking. And so when it comes to twinning our national infrastructure, we have to have that same awareness. Now, it doesn't mean that this should be stopping us from digitally twinning, but it does mean that our industry as a whole should become much more aware of how to respond when it happens, because most cybersecurity experts say it's inevitable. At some stage you will be hacked, or your physical asset that is connected will run that risk. So a lot of it comes down to how well can you respond to that incident when it happens. I've seen examples of this in the UK where large tier 1 contractors have a breach into their systems. And they might be down for a couple of weeks, but it ends up costing them millions of pounds just by virtue of not having access to the data from their projects. So it's not something that's, conspiracy or movies. This is happening. The only difference is that you're not hearing about it in public because these are private entities and companies that don't want to scare their shareholders. So a lot of these incidents don't get reported or publicized. But some countries like Australia have now mandated reporting cyber physical incidents on critical infrastructure as well. Then with digital twins, another concern is privacy. So in the UK and EU, we have strict GDPR rules that we have to adhere to. So one of the key things that we have to think about is if we're going to monitor people's use and behavior in spaces or cities or with our infrastructure, how can we ensure that those participants are anonymized? So actually privacy and ethical concerns is one thing from a policy standpoint, something that could be inhibiting us from developing twin systems. Okay, and then with AI, I already mentioned this, that actually AI, as I see it, it's kind of like the water that then helps grow and nurture those 3 core areas of technology evolution of modeling, monitoring, and simulation. And then another thing that I wanted to introduce, which is the information flow. So this comes from Professor Yanis Berlakis. He talks about the burger bun analogy. And one of the things he talks about here is using the burger as an analogy to describe how information is flowing between both the government and the business side to the final end users, which could be a human or it could be machinery. So in our industry, we're still very dependent on the human within the loop. But as we progress over time, much of this will become more autonomous. So we might be talking about machine users. We might be talking about robots on site. Yeah, let me just go through that. So the middle of the burger really represents the information flow. At the top of the burger are the end users, the human users, whether that's your construction manager, your building site operator, the asset owner, the facility manager, or the machine user. We could be talking about a tower crane. We could be talking about a cleaning robot that's just cleaning the rooms within the building that's finished. And at the bottom of the layer, we have the final sort of the client that then dictates that information flow. So who is owning that twin? Is it a government entity or a private business? And in the middle here is the security index layer. So this is the area of opportunity where we need more businesses and we need more innovative solutions to help us both secure that information as it flows between those 2 entities, but also make it easier for the data to flow between the different stakeholders within our industries. Things I wanted to highlight, why might this book be relevant to you? Well, if you haven't really yet familiarized yourself with what digital twins are, this is kind of like the introductory book. We wanted to write it in a way that's easy to understand. It's not a technical book. It's more like a brief introduction. We've kept the book short, so it's pretty easy to read. We wanted to make it something that anybody from industry or academia can pick up and just get a brief introduction to the concepts. The book is available on Amazon as well, but I've now put it up on our website. So if you want to get access to the book, you can go to our website, Twin Systems. If you have any issues, you can also email me on that email address. And then another thing I wanted to highlight is that if you sign up to the website, then the next time we're doing a talk, you'll find out when we're doing a talk online, because we're planning to do online talks with both myself and the co-authors. So you can join on those calls, and you can even do direct Q&As with my co-authors. Another thing we have is videos, because let's face it, not many people read books these days. video content is very important. So we wanted to create video content as well. And we do have a YouTube channel, and we have short videos where I and my co-authors talk about these same ideas and present the summarized short clips about the key messaging from our book. And now on to the research work. So what am I doing at Cambridge? So Project Restore is an EPSRC funded project. This is a collaborative research project that we're doing with the University of Birmingham. And one of the problems we're trying to address is the reuse of steel. So not the recycling of steel, that's being done almost 85% of the times. Traditional recycling of steel is quite energy intensive. So about 87 to 93% of construction steel is recycled, and only 7 to 13% is directly reused. In the UK, at least, in cities like London, there's an increased demand and pressure for us to reuse our construction and demolition waste. So one of the challenges comes, how do we create increased confidence for structural engineers to actually disassemble steel and then reuse it rather than go through the carbon-intensive recycling process? And that's what Project Restore is trying to do. So part of our initiative is to try and do non-destructive lab-based testing of steel samples, steel members, and then to digitally twin their performance. So try and get the real-world performance of steel members that have typical damage like dents and corrosion, to try and digitally twin that so that we can embed it into a design tool, a design software that can be used by structural engineers. The work isn't done only by ourselves. So from the University of Birmingham, this is the team that's responsible for the non-destructive testing. And most of their work is based on, doing these tests within the lab, collecting the data, and then digitally twinning the steel sample members. And then from the Cambridge side, we're responsible for the generative design tool to try and embed that information into BIM so that the structural engineers can actually create new building structures with a combination of both reused and recycled steel. So this is just outlining what the Birmingham University team, one of their key work packages is to try and, of course, generate a more accurate representation of the wear and tear of these steel beam samples. And these are some of the images from the lab-based testing of existing damage scenarios with dents and trying to capture and monitor and digitize that. So, there's typically a lot of dents and damage that results as a result of deconstructing our steel. And also things like corrosion is something that we're also doing testing and then monitoring that on the steel samples. And then the key part is to then digitize that in order to create a digital twin of that existing steel beam member. Here's again another example of some of the beam test setups with the actuators on site. And then finally, where we get to the digital twins, to actually create a digital twin of that steel member and its performance. So what we're really trying to do is minimize the gap between the red and the blue lines to try and make our simulated models as accurate as it is in the real world. And that level of accuracy and fidelity is also another critical element of digital twin-based research. In this case, our use case is very much confined to construction steel. And then for the Cambridge side, what we're trying to do is then take that information and to try and embed that into the design tools so that the structural engineers can now combine a new structural design with the use of generative design. So this is just an image here of the existing catalog of steel members that have been digitized. And then part of what we're trying to do is then to catalog those steel beam members and then try and match them into a sequence of a combination of both reused steel members and then new steel members into different configurations for industrial buildings. So in this case, we're only focusing on industrial portal frame structures, and to try and combine both reused elements and new steel elements. And then I have a video as well of Soheila's work, where you can actually see the web-based interface that she's developed. And so, yeah, like I mentioned, less than 15% is actually reused. And the reason for that is because structural engineers, do not want to take that risk and do not have the level of confidence to specify reuse steel. But if we were to, imagine our industry going forward by having more accurate digital representations of reused steel members, we could potentially eliminate some of their concerns. So this is just showing, again, Soheila's work with the matching algorithms to help specify the reuse members. And this is the web-based interface where you can modify both the overall structure and then match the existing steel beam members. So there is also more research work. So Restore is just one part, but we also have a digital twin operations research group, which is a combination of both postdocs and PhD students. And there, one of my PhD students, Hank, is focusing on interaction with digital twins. So his work is focusing largely on how do we help enable interaction with natural language-based or large language models-based chat interfaces. So in his case, he's focusing on a road digital twin. And one of the databases that we're using is from Highways England. And it's a segment of a road which is combining both the 3D models, point cloud scans, road maintenance data. And what he's trying to do is make it easier for road asset owners to extract information, query that data, maybe summarize that information, and even visualize segments of that information. The reason for doing that is because most of the software today is a very complex graphical interface. You have to have been trained, specially trained, and upskilled to be able to use that. And most of our asset maintainers, operators, facilities managers haven't received that training. And so one of the ways that we want to alleviate this is to actually try and introduce large language model-based interaction with a chat, kind of like a chat bot that can query that design data and even modify some of those design parameters. And Hank has been able to do some very kind of initial basic functionality with that for road asset owners. But the thing is that it's not only for road asset owners that could be using this. If you think about policymakers and the general public, something like a simple chat interface could be so much more accessible to the general public when they want to find out about, an existing asset, an existing road network, for example. So one of the things that we have in the scope of the tasks is we have 5 functionalities right now: data visualization, data summarization, performing changes, and also visualizing segments of the point cloud data, and even cleaning up point cloud data with text-based prompts, generating simple Gantt charts or work schedules. And we actually have a short video as well that then summarizes what that looks like. So here's a quick preview of what Hank's platform looks like today. It's changed a little bit since this was initially shown, but again, there's really 5 core tasks that we're working on. One is to then provide data visualization. This could be through, accessing existing databases about what's been done or changed on the road network, where there might be potholes or cracks on the road. So here is an example of data visualization, data summarization. So it's a much more intuitive user interface, and you're seeing this a lot these days. But for people within our industry who haven't had the chance to train and upskill with the softwares that we're using, this becomes a much easier point of access to understand that design information. This is showing visualization from a segment of the road network and model, and then basic generation of Gantt charts or work schedules. So yeah, that's Chat Twin, essentially, our research that's focusing on large language model-based interaction with digital twins.